Is this quadratic equation in a form where I can just look at it already and determine what the vertex is? Yes, it is. So what is the vertex? The vertex is... There we go. Yeah, let's go in order here. So let's find the vertex. I'm going to slide this up so y'all can see what I'm doing here. All right, so your vertex is 3, 2. All right, so it says start with the vertex. Then you're going to find the intercept. So let me remind you, if you have forgotten, to find the x-intercept, you let y go to 0. To find the x-intercept, all points that cross the x-axis, those are called x-intercepts, and they all have y values of 0. That's why they're crossing the x-axis. So to find the x-intercept, you let your y value go to 0, and what stands for y in this equation? Your f of x, okay? So you're going to let your f of x go to 0. So you're going to get 0 is equal to x minus 3 squared plus 2. And then to find your x-intercept, you're going to solve that equation for x. It's the only variable in your equation. So to find the x-intercept, you let your y value go to 0 and you solve for x. And whatever x value you get, that's where your parabola is going to cross the x-axis. So to solve for x, I've got to subtract 2 from both sides. Then I get negative 2 is equal to x minus 3 squared. I can't add 3 yet to both sides because that minus 3 is being squared. So my next step would be to take the square root of both sides, and then my brain says stop. Why would my brain say stop? Can you graph imaginary numbers? Because we're trying to find an intercept here that you can graph. So I know I'm going to get imaginary numbers because I'm taking the square root of negative 2. So what that means, I'm going to stop right here, and that means there's no x-intercepts. We'll do several examples where you see where we can find x-intercepts and when we can't. So there's no x-intercepts. That means this parabola will never, ever, 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 ever in its entire life cross the x-axis. That's because we're getting those imaginary numbers right there. So there are no x-intercepts here. You don't have to write no x-intercepts, but these are your notes. All right, and let's go find our y-intercepts. So to find any y-intercepts, we're going to let our x value go to 0. To find y-intercepts, those are points on the y-axis. Every point on the y-axis has an x value of 0. So our f of x, we're going to go ahead and write that as y equals, and then we have parentheses. In the place of our x, we're going to put in a 0, minus 3 squared plus 2. It's a little bit easier to find a y-intercept in these types of problems than it is an x-intercept. Then you're just going to simplify the right-hand side using your order of operations. So I would do the parentheses first. 0 minus 3 is negative 3. And then what would I do next? Square the negative 3 and get a positive 9. And then add 2. And then I would find out that my y-intercept is 11. So these are some things that I know about my parabola. I know that the vertex is at 3, 2. I know that my parabola is going to cross the y-axis at positive 11. And this is important too. I know that my parabola has no x-intercepts. If you graph a parabola that has x-intercepts, then you're not graphing the right parabola. All right, so let's graph what we know. So let's graph, our vertex is 3, 2. Ooh, that's big. Our vertex is 3, 2. We have another point up 11 on the y-axis. It's a little bit off my graph, but just pretend there. Now, what we're setting up for you is we are going to graph crazy polynomial roller coaster graphs that we don't know a whole lot about. We know a lot about parabolas. We know that they either go up, down, left, or Right, we know they're skinny, we know they're fat, we know we can move them around, but they're trying to teach you some techniques with the parabola that you're going to have to use with graphs that we really don't know a lot about. Okay? So this is one thing that you can do. You can find important points on your graph like intercepts. So if my vertex is at 3, 2 and the graph crosses the y-axis at 11, that tells me that my parabola is going in what direction? Up or down? Okay? Y'all get that these are not going to go left or right because they're all y equals parabolas. So, and I also know that a parabola is symmetric. So could I not get a third point straight across to the right of the y-intercept? Could you not come up with another point since parabolas are symmetric? So are y'all with me? So you could actually go right here. I'm just doing the yellow so y'all can see what I'm thinking. So could you just not go over to the right? How many units from that y-intercept? 3? 6? And you could put another point there because you know that parabolas are symmetric. You're going to need at least 3 points to graph your parabola. Parabola's a little bit more complicated than a line. A line you just have to have 2 points, but a parabola you would need 3 points. So we could sketch in that line, that parabola, excuse me. So it says find the vertex, find the intercepts, sketch the graph, give the equation of the parabola's axis of symmetry. So let's draw it in. Let's draw in the axis of symmetry. The axis of symmetry will be a vertical line that goes right through the vertex of the parabola. It's imaginary, okay? But if you want to sketch it in, you can because they need the equation of that line. What's the equation of my pink line? We're going to abbreviate axis of symmetry, AOS. Axis of symmetry. They want the equation of the vertical line that goes right through the middle of your parabola touching at the vertex. It's vertical. It's one of our common graphs. If it's vertical, the equation has to have an x in it, and every x on that line is equal to what? 3. Every x on that axis of symmetry is equal to 3. So there's your equation for your axis of symmetry. And then finally, let's talk about domain and range. Domain, we're looking for the x's, so we're looking from the left to the right. What's the domain of this parabola? Negative infinity to positive infinity. And what about the range? How low does it go? 2. How high does it go? Positive infinity. Okay. We're using a bracket at 2 because our parabola is solid. We don't have any holes in our graph. So we do have a y value of 2. That's the smallest y value, and it goes up from there. Okay. We're going to start using a lot of algebra to get us ready to graph these much more complicated graphs than the parabola. But again, they're using the parabola because it's something you're familiar with and it's not a very complicated graph. All right, moving on to example 2. Any questions about 1? All right, I'm going to speed up a little bit. If I get too fast, y'all let me know. I don't want to bore you. So example 2, the vertex would be, you tell me, 1, negative 2. All right, let's find our x-intercept. To find our x-intercept, we let y go to 0, so that's going to look like this. 0 is equal to x minus 1 squared minus 2. So to find our x-intercept, we let f of x go to 0 because that's our y, and then we're going to solve for x. This time we are going to have x-intercepts. Because to solve for x, first you have to add 2 to both sides. So you're going to get 2 is equal to x minus 1 squared. And then you can't move the minus 1 yet until you take the square root of both sides. So you're going to take the square root of both sides. You're going to remember that you're going to have to put in plus or minus. You're going to estimate the square root of 2 if it's not a perfect square because you're going to graph here. So just estimate to the 10th. That's about 1.4. And that's equal to x minus 1. We're still solving for x, and right now we have x minus 1. So we're going to add 1 to both sides. So our x-intercepts are going to be positive 1 plus and minus 1.4. Think about that algebra. Make sure you understand how I got 1 plus or minus 1.4. And then that's going to give us 2 x-intercepts. One is going to come from 1 plus 1.4, so I'll have an x-intercept at 2.4. And then I'll have another x-intercept at 1 minus 1.4, which is negative 0.4. If you have x-intercepts, they'll be a little bit harder to find than your y-intercepts. Alright, so far we know what the vertex is. We know that our graph has 2 x-intercepts. So our parabola is going to touch the x-axis twice. Now we're going to find the y-intercepts. So to find the y-intercepts, we let x go to 0. So that's going to look like y equals 0 minus 1 squared minus 2. A little bit easier to find the y-intercepts because the equation is technically already solved for y. So you'll do order of operations. So you'll do your parentheses first, and you'll get negative 1 squared and then minus 2. Then you'll do your exponent. That's positive 1 minus 2. And your y-intercept will come out to be negative 1. Okay? If you have done all this math right, when we graph the vertex, the 2 x-intercepts, and the y-intercepts, and we connect those points, we should have a parabola. If you don't have a parabola, then that means you've made some type of mistake. So let's graph. The vertex is 1, negative 2. I have an x-intercept at 2.4, which we're going to kind of estimate here, and negative 0.4. So those first 3 points kind of seal the deal there. Y'all see that you would get a parabola through those 3 points? Now, the y-intercept has to just fit into that little puzzle. So the y-intercept is negative 1. So if I graphed through those 3 points and then I stuck the y-intercept in there, would the parabola not go through those 4 points? You have another point, but I think you can go ahead and sketch the graph with those 4. You know, there's an infinite number of points on every graph that's continuous. All right, so once you find your intercepts, your vertex, all that should form your parabola. Again, your axis of symmetry is an imaginary line that goes through the middle of your vertex, and they want to know the equation for that line. It's always going to be x equals, because it's always going to be vertical. What are all the x values equal to on that imaginary axis of symmetry? 1. And then the domain is negative infinity to positive infinity. The range is, how low does it go? Negative 2, and it goes all the way up to infinity. Questions about example 2? All right, example 3. First of all, the equation is a little bit out of order. So what I would do is I would put the negative binomial squared, I would put that first. And then the 1 is technically positive. And I would put the plus 1 on the outside. That gets it in the correct order for you just to tell me what the vertex is. So the negative x minus 3 squared comes first, the plus 1 comes second. So the vertex of the parabola would be 3, 1. Alright, that's important. Let's find the x-intercepts. What goes to 0 for the x-intercepts? The y goes to 0. So we have 0 is equal to negative x minus 3 squared plus 1. And then we can't take the square root of x minus 3 squared yet because there's the plus 1 and then there's the negative out in front. So let's move the plus 1 first. So if we move the plus 1 over to the left, it becomes a negative 1. These are just going to start to get a little bit harder and a little bit harder. Is the x minus 3 squared by itself yet? No, technically it's being multiplied by a -1. So you're going to divide both sides by -1. That's going to give you a +1 on the left-hand side, and then you're going to have that positive x minus 3 squared on the right-hand side. And now you can take the square root of both sides. Your binomial squared has to be completely by itself before you can take the square root of both sides. So the square root of 1 is plus or minus 1 equals the square root of x minus 3 squared is x minus 3. So x is going to be equal to 3 plus or minus 1. That +3, you'll add 3 to both sides, and that +3 will be written to the left of your plus and minus. So you are going to have x-intercepts here. What are the two x-intercepts? 4 and 2. Anybody have questions about the x-intercepts? All right, to find your y-intercept, what do you let go to 0? Your x. So you have f of x equals -0 minus 3 squared plus 1. Follow, please excuse my dear Aunt Sally, and do the parentheses first. Then what would I do next? I'd square the -3. And what's -3 squared? +9, but multiply it by that understood -1, so you get a -9 there, plus the 1. And so your y-intercept comes out to be -8. Alright, so let's put these pieces together. These are kind of like little pieces of our puzzle. If they don't make a parabola, something is wrong. Alright, so we're going to graph our vertex, 3, 1. Our x-intercepts are 4 and 2. That kind of tells me right off the bat there. If you have two x-intercepts, once you graph the vertex and you graph your two x-intercepts, you'll get that little triangle, which means you've got that little curve going on, which is a parabola. So that means we're pretty good. Now we got to fit the y-intercept in. So if I connected those 3 points, would that cross the y-axis somewhere down at -8? 1, 2, 3, 4, 5, 6, 7, 8. I think so. That would make a parabola, right? So then when we graph it in, how did we already know this parabola is going down before we did any of this work?
With the negative.
The negative is in front of the x squared, so we know it's reflected over the x-axis. Alright, without drawing the axis of symmetry, can you give me its equation for the AOS? X equals 3. She's right. Domain. Domain for all up and down parabolas are going to be -infinity to +infinity. I'll say that again. Domain for all up and down parabolas will always be -infinity to +infinity. The range will not be that. How low does this parabola go? To what? 1 bracket. So you're really going to have to read the directions here. They're asking you for a whole lot of stuff. Alright, how can these problems get harder? Example 4 is going to be harder because it is not in the right form for you just to find the vertex. So you practiced that last night. So what I want you to do is I want you to take a few minutes on your own for example 4, and I want you to put it in vertex form or quadratic form. Both those mean the same thing. I want you to combine the x squared and the x term, factor out the 3. This one's going to be ugly. Complete the square, balance by doing the opposite, get it in that form so you can tell me what the vertex is. This one's going to be ugly. Okay? I'm going to pause my video. Well, if you're thinking what multiplies to be 4 and combines to be 2, you can't do that on this one because it's a harder trinomial. So you would actually have to put the 3x in the x and play around with the numbers. Would 4 and 1 work? No. Would 1 and 4 work? No. And if y'all don't know what we're talking about, you might want to come see me before or after school, and we might need to have a little individual lesson here. Would 2 and 2 work? No. 2 and 2 would be negative 6x and positive 2x. And that's not going to work. Okay? So if we could have factored and set each factor equal to 0. So sometimes that might happen, and that would be the easier way. This one's not going to factor, so you can either complete the square or you can use the quadratic formula. Really? You're going to have to divide everything by 3, and you're going to get it's up to you. I would think most of you would probably do the quadratic formula. Okay? When I told you yesterday that I hope you enjoyed the matrices section, we're going to get back to something that's more difficult. Did y'all believe me?
I didn't hear you.
You didn't hear me say that? Maybe I said it third block. Alright, so let's not lose track of what we're doing here. So that won't factor. So you could either complete the square or use the quadratic formula. It's up to you. Okay? And this is where some of you are going to struggle because, let's be honest, some of you did not get this back in chapter 1. This came from chapter 1. So here's a second chance to watch the movie again and see if you can catch all the things in the movie. So I'll go back and explain this. You're going to start to go, I have no idea what she's talking about. That's past knowledge that you did not get. Question.
What does that say? The x minus plus 42? What does that say?
No, you really weren't supposed to write all that down. You're supposed to get the idea that 4 and 1 doesn't work. 1 and 4 doesn't work, and neither does 2 and...
Wait, so what do I write down?
You say it won't factor. Okay?
Well, I can just work that into
No, you can't because...
Well, it would be difficult too, so I'm going to try it anyway.
Yeah, you can't, on this trinomial, you can't just say what multiplies to be 4 and combines to be 2 because you have that 3 being multiplied times your x squared. So those are the harder trinomials that you got to put your signs in, put the two numbers in that multiply to be 4, and check the outer and the inner products. Okay, we got to move on. So we're going to do the quadratic formula here. What's the a value? 3. What's the b value? -2. What's the c value? Next question is, what's the quadratic formula? Yeah, I'm going to have to erase again. All right, so negative b would be positive 2 plus or minus, and then we're just filling in. So that's going to be -2 squared minus 4 times 3 times -4 or +4. -4 all over 2 times 3. What's the value underneath the square root in the quadratic formula called? The discriminant. So I would suggest that you take your calculator and you put the discriminant in exactly like it looks. So left parentheses, -2, right parentheses squared, -4 parentheses, 3 parentheses, parentheses, -4. Give me the discriminant value. Some people are already there. Some people are totally lost. 2 plus or minus the square root of, I'm getting 52. You got 52? Okay. A lot of people, if they miss the quadratic formula, it's because they don't get the discriminant right. It's 52. If you're not getting 52, something is wrong. Now, we've already forgotten what we're finding. We're finding the x-intercepts. It's taken us so long to get to this point, we have forgotten. So it's okay just to take the square root of 52 in your calculator because we're graphing and we can't be completely accurate, so we're just going to go ahead and estimate here. So somebody take the square root of 52, round to the nearest tenth. 7.2. So now the quadratic formula says 2 plus or minus 7.2 divided by 6. And finally we're going to get 2 intercepts. 2 plus 7.2, get that answer, divide it by 6. $1.5. And then we're going to do 2 minus 7.2. Get that answer. Divide that by 6. Round to the nearest tenth. 9. Okay? Alright, we got to get on. We got to get on with our lives here. So those are our 2 x-intercepts. That was horrible, but this is on video, so you could go back and watch this one if you got totally lost. We're not finished. Okay? Let's find the y-intercept. The y-intercept is going to be so much less painful. So go back to your original problem. Let's find the y-intercept. To find the y-intercept, what goes to 0? The x's. So this one is going to be oh so easy compared to what we just did. This time we have 2 x's. So you'll put a 0 in for both x's. You let all the x's in the equation go to 0. The y-intercept comes out to be -4. That's where you say, oh my gosh, thank you that wasn't so hard. All right, now we have a vertex. We have 2 x's.